Radioactivity or nuclear chemistry is the easier topic in physics or chemistry, but most people don't tend to understand it. But it is simple. Let me break it down for you so that you don't have to forget again. Let's get into work. Now look at it. Look at this question. It is very easy. If the half-life of a radioactive substance N is what? Is 2 days, right? How long will it take for the substance to remain N over 16? Very easy question. What is given? We are given that the half-life, please pay attention, which is what? T half-life to be what? 2 days. Okay. Now, there are times I would have loved to explain, but I'll make a proper video on radioactivity, but this is just to explain some things. So it is, and I might even say it in this video, okay? It is this, Abi. Now, there's something we call time, the total time taking, which we say to be what? Capital T. Now, that is what they ask us. How long will it take? And that's the capital T. Now, there's a formula. There's something we call X. We call it number of decays. See, by the time I teach you radioactivity properly, you understand? Because I'll just give you the things you need. Now, there's a link between half-life, how long it takes, and the what? Number of decays. Okay. Now, what is that? I don't cram it. Look at it. For big T means it is bigger. That means for you to have something big, it must be multiplication of other smaller one. So that is why it is small t, which is half-life. I mean, half-life now. The time taken for what? For an original mass, okay, or an original atom to become exactly half of its initial mass. Very easy. That will be times x. Oh my God. If you can know this first one, you are halfway into radioactivity. How do I know this big T? Abi, how long? This is half-life. Then this is number of decays. In fact, this formula is so important that you dare not miss it. Now let's go back to the question. I just want to let you know this. Now look at what they say. That the substance is what? N. That means look at it. Look at radioactivity. N will become exactly half, which is N over 2. After how many days? Look at it. 2 days. That's the half-life. Abi, don't follow me. This would have become exactly half again. And that when it comes out, it will become N over 4. After how many days again? 2 days. Oh my God. This N over 4 would have become what? N over 8. After how many days? 2 days. N over 8 would have become what? N over 16. After how many days? 2 days. Very easy. Oh my God. Now look at it. What people don't understand, this is what they don't understand. This is the original mass. This is what is left. This is what is remaining. Look at it. Remain. After 2 days, this is what is remaining. After 2 days, this is what is remaining. After another 2 days, this is what is remaining. So the question here is easy. Now, some of you don't understand what I mean by X, number of decays. Look at it. This is the first decay. This is the second decay. This is the third decay. And this is the fourth decay. That means in this question, X is what? X is 4 because it undergoes how many decay? 4 decays. Very easy. What is the half-life? 2 half-life. That means how long? I can get it. How long is T? Oh my God. What is the half-life? 2. The half-life is 2. No pressure. What is the number of decays? 4 to get to N over 2. This is what is remaining. See, I would teach you some things. Or sometimes they use what is left. If they don't use what is remaining, they'll use what is left. Now, because we have already got it to this, because that's what they said, N over 16. For N to become N over 16. So, this is the half-life, which is 2. What is the number of decay? 4. That means the answer to this question is what? 8 days. He's saying that after 8 days, this original mass or original atom would have become N over 16. Is that not simple? Why did they crowd? Now, let me teach you another thing. There's something we call what would have decayed. Hey, look at the terminologies. What would have decayed? What is left? And then look at original. Let me just brief you on that. Maybe I will now form another question to explain the concept. But if you understand this, and the next thing I'm going to be explaining, you should not have problem at all for these questions on radar, because your physics, most especially your radioactivity question in physics, is centered on this kind of questions. But when you understand it, you don't need to cram. Let me give you the second one. Let's say we have, that means I'm done with this. So the answer is 8 days. You don't need problem. Or I'll give you another question though. I'll give you your own question so that you solve it and tell me the answer. But the answer to this one is 8 days. You already know that. Good. Now look at what happened here. What happened is actually this. I used to use an analogy. Let's say your mom gives you a particular bowl of rice, right? There's a bowl of rice. Now, and you've taken just 2 spoons. There's what is left. The whole bowl of rice is the original mass that your mom gave you. Abi, then the 2 spoons you've taken in, it is what has decayed. It is what has gone. It is what has disintegrated. I mean, this stuff is easy. Okay, now look at it. That means I can tell you that original mass. See, don't forget, if I'm using mass, don't forget it can be atom like this or atom. It's going to be what? What is left? Left, Abi, or in another term, you might see remain plus what? Plus what has decayed. Decayed. See, if you know this, I bet it with you, you can almost solve all the radioactivity question in physics. Now, it looks simple. This thing is simple. It's not that it looks simple. That, of course, now, original mass, like the whole everything that you have, should be what? What is left and what has gone now. Because if I ask you a question now, this is what has remained. What has gone? If I can choose this question and I will tell you that 15n over 16 has gone. How? Because I know this one is n. Now, what is remaining is what? N over 16. Now, x is what is left. It is what has decayed. Or don't let me use x because of this. Let me just use y. Just make y the formula. Then you have y equals to what? N minus n over 16. So that is why this make sure you save this video. You need it like anything. Make sure you save it, share it, and comment. So n, which is what has decayed, what has gone, it becomes what? LCM 16. How many one can you say? 16. 16 times n, 16n, minus how many 16 can you say? 16. 1 times n. That is why it is what? 15n over 16. This is what has decayed. Oh my god. After this time, the half-life, after 8 days, this is what has decayed. N over 16 is what is left. The original mass is n. Oh my god. Very easy. This has decayed. A lot of students have been asking me questions on radioactivity. This is original, and this is what is remaining left. Okay, let me give you your question. See what I just did here. It looks simple, but it's the basis of radioactivity. Now let me give you the physics radioactivity basically. Let me give you. Let's say the half-life. Drop it in this comment. If you don't drop it, I will not answer your question again. Okay? Yes, because you asked me to do this, and I want to know if you actually got the concept. Okay, so if the half-life of the radioactive substance N is, let's say, 8 days, let me now put this one to be what? To be let's say 32. So calculate how long. Of course, you know how I'm getting half now.